In this session we will discuss about signals in general. So you are seeing a picture of a flower. So this flower has different color, shape. So this conveys some information to you, such as its color and shape. So we can see a signal is anything which conveys some amount of information. Now we will see some examples of signals. As you are already familiar, S1t equal to 5t, S2t equal to 20t square. They are all examples of signals. Other examples are the speech signal. Now I am going on talking about something. So at different instance of time, I have different values of sound signal. So this is called as a speech signal. The same way, when we record the activity of heart, we get for a different time period, the heartbeat goes on changing. So you will see that it is almost periodically repeating. Now we see the most important classification or type of signals. So there are continuous time signals and discrete time signals. So these are two broad categories of signal. First we will see analog signal or a continuous signal. The analog signal are defined for all values of time. It is important to note it is defined for all values of time. The example is a ECG signal, which we have seen before. So the activity of heart is there for all values of time. Or we can see a cosine wave. So the amplitude of the waveform going on changing with respect to time. So it can be written as x of t equal to 10 cos 2 pi into 50t or 10 cos 341.4 t. The amplitude is 10, frequency is 341.4 or is 50 Hertz. Now we see the other type of signal as discrete signal. If I measure the temperature of the room at every hour, for example, I measured the value of temperature at 8, 9, 10, 11 and 12 o'clock. We get the values at 8 o'clock is 20 degree, 9 o'clock 22 degree, 10 o'clock 25 degrees, 11 again 25 degree, 12 also 25 degree. So the value is measured only at every hour. So we are not measuring any value of signal between 8 and 9 a.m. or between 9 and 10 a.m. We don't have a value of that signal. So a discrete signal has values only at discrete instance of time. Here like 8, 9, 10, 11 and 12. Now we see basic sequences in discrete signal which we will be using throughout the course. The first one is defined as unit sample or impulse sequence. So you will see that the value of the signal is defined for n equal to 0, n equal to 1, 2, 3, 4, 5 and so on. So the value is 1 only at n equal to 0 and the value is 0 for all other values. So mathematically we can represent delta n is the sequence equal to 0 when n is not equal to 0 or delta n is 1 when n is 0. Now the second type